Thank you. Thank you for that warm welcome. So, as I said, this is, as he said, this will be about Kubernetes. I saw a good show of hands of people. Are people using it in production already? Yeah? Okay. All right. Cool. All right. Ask a couple questions about you. I know someone asked this earlier, but I was upstairs and I couldn't see. Who here is like developing full time? Okay. Who here is doing operations full time? Who is doing both? Damn it. All right. Okay. All right. Good. And the question was, how many people tell people who do operations or development what to do? How many managers are in the room? Good. Manager jokes fly. Sorry to the one or two hands that flew up. All right. Give me a good grounding. And how many people are already familiar with containers and Docker in general? Not a value judgment. You're not saying you agree with it already, but just that you're familiar with it. Okay, good. So I could skip some of the, here's what containers are. All right, so let's talk about what is Kubernetes? Why do you need this thing? What problem are we trying to solve with Kubernetes? So, okay, so you've come over to containers, right? And this symbol, this little cog with a wheel and all that, that's going to be a container, as you see, as I have diagrams to get more complex than this. So, okay, so we have an app. It's a very simple app. It is PHP and web front end, and here's sort of the abbreviated Docker file for it. And we've got a back end. It's running MySQL. Okay, pretty simple, pretty basic. I now have my app. I've got two containers. One is talking to the other one. Everything's set up. Everything's working great. All right, if I need to scale up a little bit, I can scale up the front end pretty easily. Fantastic. Someone points out to me, though, that this is really a suboptimal way of doing this, right? I really should split up front end from API and the actual app, right? I should have front end and being served up by a web server and the API level served up by another machine. So, okay, so I'll split this up. This is now just services. And then I will split and have just an Nginx box running my front end. Okay, a little bit more familiar kind of architecture here. I've got a 3-tier app going. And again, if I need to scale up, it's fine. Now, I'm running MySQL in a container. Containers are ephemeral, and backend storage and ephemeral go together sort of like oil and water, right? This is not a good idea long term, because we want to, containers should be ephemeral. So I'm going to add some persistent storage, so if this container goes down, all of my data is stored and people can sleep at night. Okay, so now my environment's gotten a little bit more complex, but if I want to scale out even more, and I want to scale out, maybe set up a replication server, I can do that. All right. Now, this is all great, and I've got my big system here, but this is really an abstraction because underneath the covers here, I still have memory, processor, and disks that are being utilized, and having all of this gigantic, having all these containers split up, great, but I'm still got a single point of failure. All right, so I'm going to set up another box, so I'm going to kind of divvy up my containers amongst them. And then, let's say one of those boxes goes down, I have to move my containers over to another machine, and now that's a lot to manage, right? So I've got a lot of stuff going on. Kubernetes is sort of a different way of doing it. I set up some resources, and then I say, I want 4 of these, 3 of these, 2 of these, make it happen, and Kubernetes does that. So that is the basic problem we're trying to solve here. So Kubernetes is a container orchestration system. It is open source. It was started by Google. But now it is contributed to by many others. Let's see, the big ones are CoreOS, Red Hat, IBM. So those are the big ones, and a whole number of smaller companies are contributing as well. Okay, concepts, how do all these pieces work together? How do they fit together? So there's a couple concepts you need to know. Have you guys heard cattle, not pets before? See some? So it's pretty basic. Pet is something that has a name. It's unique or rare. It requires personal attention. And if it gets ill, you stay up all night and make it better, right? Whereas with cattle, it has a number. One is pretty much like any other. They run as a group, and if one gets ill, you make hamburgers. Here's what I'll point out from an animal husbandry standpoint. That's probably not what you want to do. You want to make a leather coat out of it. Do not eat hamburgers from cows that have gotten sick. So kind of coming over to containers and computers, we kind of understand how that is, right? We have pet computers and we have cattle computers. We want to move to a place where our systems are cattle and not pets. Another concept that comes in Kubernetes that I would call employees, not children. You basically tell Kubernetes, this is what I want my environment to look like, as opposed to having scripts that set up your environment. So what I mean by that? So with an employee, if you've had a rough day at work, you tell them, hey, we had a tough day, go home, get some sleep. And that's it. That's all you have to do to have that employee go home and reach some state of rest before they come back, right? No judgment on what that employee is doing when they get home, but eventually you assume they go to sleep and they get rested. If you have children, you understand that children, bedtime goes something like this. You tell them, go upstairs, get undressed, put on pajamas, brush your teeth, pick out 2 stories. For those of you that don't have children, you're wondering, do you really need to tell them to go upstairs? And the answer is yes, because you look at the next step. If you don't tell them to go upstairs, you'll have a naked child in your living room. And servers are same sort of thing. If you have a set of scripts that one of the steps gets missed or gets misfired, then you end up with a down server somewhere. Okay, so Kubernetes works in this sort of declarative environment. You just basically say, I want 4 machines, 3 machines, 2 machines, whatever. What are all the components of Kubernetes? Now, I'm going to go through a lot of things in a very short period of time. Kubernetes is complex. There's a lot of complexity in it. And so there's just a lot of pieces that you have to kind of be familiar with before we can kind of talk about it. So, okay, first is container. If you guys are using containers, using Docker, you can use Dockerfiles just exactly like you use them in Docker, you can use them in Kubernetes. So we like to look at containers as the subatomic particles of Kubernetes. You would never actually have a container. You'll have another construct that I'll name in a second. But if you have Docker files that you're using with Docker on your local machine, you can take those same Docker files and use them with Kubernetes, and they work. If you're using some of the features of Kubernetes, you may need to alter your Docker file, or at least kind of put conditionals in there and saying, if I'm running on Docker, do this. If I'm running on Kubernetes, do this. But you do that at the development level and not necessarily at the container level. So now we get to pods. Pods are what we call the atomic components of Kubernetes. So this is the smallest unit of something you would deal with Kubernetes. They are made up of 1 or more containers. And what that means is they'll share IP address, namespace, like local storage. Now, all the documentation say like 1 or more containers, 1 or more containers, 1 or more containers, but it's okay to just have 1 container. And in fact, most of the time, I only have 1 container in a pod. But why would you want more than 1? The canonical example we use is of a web server and a file sync. So if you have a perfect containerized workload where each container is only doing 1 thing, and you have files that you're serving up via the web server, you would have the web server be 1 container. You would have the file sync to get the local files be another container, and you would have them both in the same machine so that when the file sync comes in, it would write to the machine, write to a space where the web server can serve from. The other big example I see with this is, let's say, now, no one in this room has ever done this. Right? So this is somebody else, right? This is my friend did this. But let's say someone set up like an all-in-one's like lamp box, right? Like I know, none of you guys. But let's say you did that and you want to move to a container environment because running on a single box is sort of scary, but it happens, right? Like something was a test and now it's mission critical. So what you could do is, instead of having to rewrite all the code to kind of change the fact that you're calling to localhost, you could put all of these things into multiple containers in the same pod, so you don't have to change the development going forward, and then over time slowly break apart the services into a more correct architecture. Okay, so the next unit is something called controllers. There is really only 1 type of controller, and it's called a replication controller. And what it does is it observes the environment. So how many containers am I running? So let's say I'm supposed to have 4 web servers. Observe, how many are there? oh, there's 3, there's a diff. So there are 3, there should be 4, so I'm going to act and launch another one. These containers just kind of continuously run and make sure that at any time, if the desired state and observed state are different, it'll switch between the two. Now, there's also this thing called a replica set, which is new and is pretty much exactly interchangeable with a replication controller. How you set them up is just slightly different. It's actually smaller, the configuration you need for them. The reason I bring this up is that replica sets are probably what you want to do going forward, but all the documentation points to replication controllers. So if you get to the documentation, you see replication controller, you can just sub in replica set, and it's all fine, right? So replica sets are made through what's called a deployment. And a deployment is basically, it could be a replica set, it could be a couple other sets. Pet sets are another one, because even though I said cattle, not pets, we know that some people want pets, and we're sort of honoring that. There are a couple other types of deployments. Job sets are another thing. So if you've got things you're going to spin up just to handle a particular workload and spin it down, you can use that deployments to do that. Next is services. So we have all these machines, and with containers, you're not supposed to care about them, right? You're not supposed to care about what their IP address is or how to reach them or anything. But at a certain point, you do need to care about that, right? Like if you have a MySQL server on the back end and you want the PHP servers or whatever front end you're running to get to them, you do need to, at some point, have a way of communicating between the two of them. And the way we do that is something called services. So services defines, you set up a set of pods, and you say, these are my back-end boxes. And so it creates a DNS entry on the Kubernetes cluster for back-end. And then all your development code, all your code in the front end can point to back-end in order to get in communication with it. They get a virtual IP address. Now, they can be private, or they can be public. And so this is a really useful way of exposing Kubernetes to outside actors, right? So public web address, or if you need somewhere else in your infrastructure to call a Kubernetes service, you can do that through services. Last thing is networking. All pods are IP routable, meaning any pod can talk to any other pod directly. You don't, under Docker, and I know I mentioned some things today that this isn't exactly, but under Docker, most of your communication goes through the Docker host. With this, the individual pods can talk with one another, even across hardware nodes. So it's really useful. All right, so to sum up, Kubernetes uses containers, right? But you never actually use a container, right? You use a pod. But you actually never actually call pods themselves, because pods don't have the idea of replication in them. So if you launch a pod and a pod goes down for whatever reason, the pod will not resurrect. So you need something called a replication controller, but you don't use replication controllers anymore. We use these things called replica sets. But you don't actually use replica sets directly. You call them through deployments. You make all this available via services. Simple, right? Right? Why? Why is this so complex? Well, there are a number of reasons. One, we're trying to manage a lot of complexity, and we abstracted a lot of it away, but at the end of the day, there's just a lot of complexity there. The other part of this, especially around replication sets and deployments, so we see it's a very active open source project. And in fact, the other day, I did a hackathon, and I was trying to give credit to people. And so I went to the day that we had the hackathon to try to figure out how many pull requests came from the hackathon. And we get on average about 30 pull requests a day on Kubernetes. So it is a very active project. And so that's why some of the stuff is in flux. I want to show you Kubernetes running. I'm going to show you a real example of an app running on Kubernetes. Before I do the demo, though, I want to kind of I yada-yada'd a whole bunch of stuff here, so I want to make sure that I make it clear what I did. So back in my hotel room, I launched a cluster running Kubernetes. I created a disk in order to store MySQL. I also created multiple Docker images that I uploaded to a repository. All of this takes anywhere between 2 and 10 minutes. If no one is watching, it takes 2 minutes. If you're in front of an audience of people, it's going to take 15. because that's just the way it works. And it's sort of boring. It's like a whole bunch of like script going up. So I figured I'd explain what I did, and this is sort of how your base Kubernetes would be, right? Like it's already running, and you just want to launch some containers. So that's the point where this demo starts. The app is a very simple, only 2-tier PHP and my SQL backend. It is, I know this is shocking, you've never seen a demo to do app before, but it is very simple to do, so that's why it is. Behold my awesome use of Bootstrap. All right, and so let's see this demo in action. So can you read this script in the back? We're good? All right. So instead of me typing a whole bunch of stuff and fat fingering it, I use makefiles. So it should print out all the individual commands. So we're going to make, I should show you this. This is a visualizer. It's going to show you kind of what's happening as these things come up. So let's see. We're going to make deploy. And you'll see that I'm running a few kubectl commands, and I've created a PHP front end and service, and a MySQL pod and service on the back end. Now, the dark green means it'll be publicly available. The light green means it'll be only private. The yellow meant that it was starting up. MySQL takes a couple seconds to start up. My environment is all ready, but I don't have a public IP address because I'm waiting for that from the load balancer. It takes somewhere between 10 seconds and a minute. Again, when it's being watched, it gets shy. But while I'm waiting for that, I'm going to show off something else, which is, so here you can see, because these are deployments, you'll see these really long names for the pods, because, again, I don't care about an individual one. They're like cattle. But what I'm going to do is I'm going to show you how much I don't care about them. I'm going to kill one of them. kubectl, delete pod, all right? And it's deleted. Now you'll notice that it went red and went away, and then the yellow one spun up. And the reason why that happened was because the replication set is set up that there should always be 2. So because the set wasn't the same, it immediately launched another one and was ready to go. Now I have a public IP address now, so I will open up a link, a new tab. We'll see. I did this in my hotel room to provide. That doesn't even make sense, I'm sorry. But I'm going to do it live again. So. Again, save, there we go. All right, now something crazy happened. I know this never happens in your environment, but the designers came through and said that light UI is not going to work anymore. All cool apps are done with dark UI now, so we need to change it, right? This represents a code change. In this case, it's just CSS, but it could be anything. But this is a visual demo, right? So I'll do it via CSS. So I have new CSS that I want to apply. I make a different Docker image. I build it, I upload it, and have it be available. And I want to do a rolling update. I want to swap these out. That is also something I have set up with a file here. So I'll say make update. Now, this is a rolling update, and you'll notice that it's going to roll pretty fast. You can configure this because this is a demo in front of people. I like it to be really fast, but you can have it roll over many iterations. You'll see the new one is up and running. If I hit refresh, there we are, our cool dark UI. Now I want to show one more thing, which is that one of the great things about Docker, one of the great things about Kubernetes is that I can run I can run a whole environment, a whole system. And a lot of times, talking to people, one of the things they value is that they're kind of dipping their feet. They're trying to get new stuff in here, and they've got the marketing wants a WordPress site set up for a very limited amount of time, or they want something that we don't want to run. So you can run it on us on Kubernetes. So let's see, where is that? That one. Go. Make deploy. So I'm going to spin up a Drupal, a WordPress, and a Node app. And they're all going to run in the same environment. The front end goes back to the light end, because that's the script I was pointing at. There we've got Drupal running. There we've got a Node app running. And there now we have WordPress running. So with a little bit of scripting, a little bit of makefiles, I'm able to create pretty much a data center's worth of apps, or a small data center, right? That's only 4. But very quickly, I can spin up an entire environment and have it running all of that. Before I move on and show, because I need the public IP addresses, any questions about anything I've shown so far? And I have a microphone in a box that I can throw at people, and this makes me very excited. So anybody have a question? No? No? I would throw it gently, right? No? All right. All right. I don't get to use the microphone. So okay, let's see. I've got time, so I'll let that spin up. So yes, let's see. I'm on Drupal's first. So I can spin up. There we go. Welcome to, I've got that running. Here's my Node app. My Node app is pretty simple. It is an app to just, it doesn't even have a back end. It just shows off animated GIFs that are creepy. It was the creepiness scale, walk-in being the bottom of the creepiness scale because he's kind of creepy, but if you really weigh it, like, he's not really, he's kind of harmless. Busey is next. Gary Busey is the next, the creepiness scale. And then finally, I've got my WordPress site running. So I've got a whole environment running relatively quickly, up all with Kubernetes. So cool. Let me close this down. I'm just going to do the responsible thing and shut down all of these guys. Now I'm going to shut all of these down at once. The visualizer does not like that, so it gets really ugly. There we go. It's looking okay when stuff starts breaking. Okay, well, I will move on. All right, so that was Kubernetes demo. Now, we also talked about rolling updates, which I showed off. We talked about persistent volume, which was running MySQL in the background. There's a whole lot more to Kubernetes. There's a secrets API, so if you want to do things through environmental variables and you don't want them stored, and you shouldn't want them stored anywhere, you can use secrets to store them. There's logging, there's monitoring, there's events. There's a web interface. There's not that's just a demo to show off this, what's happening. There's also a jobs API, so like you said, if you want to spin up a whole bunch of containers just to solve a certain problem and then spin them down, you can use that. And then the cool one here is horizontal pod scalar. So right now, I sort of set a replication set and say, always be running 4, but it's possible that those 4 would eventually fill up. And so what I can do is set, if the processor utilization gets too high on these pods, spin up more pods. Now, eventually, you'll run into the limit of the size of the node it's on, the Kubernetes cluster, and Kubernetes has no way of dealing with that internally, but several of the ways you host Kubernetes can handle that and spin up more nodes for you. Quick couple of comparisons, because people ask, like, what about Docker Compose or Swarm or other things? So Docker Compose allows you to run multiple containers on the same local host. Docker Swarm allows you to do container of hosts. Docker Machine allows you to manage remote container hosts. Docker has a very, I would say, Unixy philosophy behind it, right? Like all these individual tools that do one thing really well that you combine together for effect. Kubernetes is sort of an overarching thing, so it can do all of those things, plus has replication controllers, routable network, replica sets, auto-scaling, all of that. Also, Docker's logos are much cooler than ours, and my hat's off to them, but it bothers me for us that Docker is like, they have like an artist that does these, and they're amazing. I figure I'd call that out. Container engine. Now, up until now, I've mostly talked about developing on Kubernetes. I haven't talked about what it is to that the whole thing I yada that like I set up a cluster. So you want to set up a cluster. First, you need to choose an infrastructure. You can choose Google Cloud Platform or AWS or Azure, Rackspace, on premises. I certainly have my opinions on where is the best place to host it, but you can host it on any of these places. And do so happily. Then you need to choose a node OS. You have lots of options. CoreOS is a really good one for it. We, I think, run a flavor of Debian to run it on, but to each their own. Then you need to provision the machines, boot VMs, install and run all the kube components. right? Okay, and then you need to configure networking, IP ranges for pod services and service discovery network. Then you need to start cluster services like DNS, logging, and monitoring, and then you need to manage the nodes, kernel upgrades, OS updates, hardware files. Okay, all right, we're done. All right, we got a cluster set up, it's all ready to go. Or the alternative is we have this thing called Container Engine. You go to Google Cloud Platform, go to Container Engine, and there's a button, and you press the button, and you don't have to sit through all of that. So I'll talk about what you want to do with that. So Container Engine is hosted Kubernetes. A few smart defaults are set. Things like logging and monitoring are all set up for you already. DNS is all set up. And what I really like about it is it allows you to sort of dip your feet in. The development part on Kubernetes and containers is difficult, is challenging. It's a new way of doing things. There's a lot of benefits to it, but it alone is difficult if you have to set up Kubernetes, which is its own ball of wax, before you test to see. It's hard to kind of figure out if, you get through all of this work just to get there. Cognitive dissonance takes over. You start to say Docker all the time, like every other person who's working on containers. It's ugly, right? So Container Engine sort of allows you to dip your feet in. So it also allows for node auto-scaling. There are a couple other solutions that can do this. Mesos can also do this. But if you run a Container Engine, you can set up your nodes to auto-scale. So you can have your pods auto-scale, and they'll use up more resources on the node. And then when the node gets used up, it'll spin up more nodes. So quick conclusions to bring it home. If you like what you're hearing about Kubernetes and you're wondering what the hell am I getting into here as I went through the whole explanation of clusters, I really recommend Container Engine for making dipping your toes in a little bit easier. One of the cool things we have on Google Cloud Platform is if you sign up for an account, you get $300 for 2 months for free when you start up, and we don't bill you until you press a little button that says, okay, start paying for this. So you can use your $300 in free credit to try out Kubernetes on Container Engine and then decide whether or not it makes sense for you. And if it does, but you want to run on AWS or on-prem or somewhere else, you absolutely can do that. And we absolutely encourage that. We'd love to see you try that. No, I'm serious. I'm not joking around. It's okay. We want you to use Kubernetes. It's okay if you use it somewhere else, I swear. We at Google have been developing and using containers to manage our applications for about 10 years. We have a few stats on this, but long story short, we launch about 2 billion containers a week in some way, shape, or form. So if you're using Gmail, you're using search, you're using everything, you're running on containers already. We think that at the scale we deal with, as I like to say, over 2.5 billion searches a day on a universe of 600 trillion URLs, that 20 billion of which update every day and return results in 250 milliseconds. We have scale issues. We have massive scale issues. And so we think containers are the way to handle that scale. You should carefully consider whether or not running everything in containers is right for you. And I want to make that very clear. I don't want you walking away and saying, the Google guy said, we should run everything on containers. No, you should carefully consider whether running everything on containers is right for you. There are cases, isolation and scale, I think, are the real big things. Being able to run just one small set of containers for an old version of your code or running an old software package is great. That's the isolation part of it. Scale, when you need to ramp up between 0 to 1 million requests in a very short period of time, containers really solves that problem well. But if you don't have those sorts of massive scale or isolation needs, make sure it's right for you and make sure that it really fits in your environment. And with that, I will say thank you. If you want this Prezzo, it's available via that link. They encourage you joined in voting, so please feel free to give feedback there. Any questions before I go? I promise I will toss the microphone. I came off a little overzealous there. Any questions? Going once? Going twice? All right, thank you guys very much.